Hello students. So this is Springs part 6. In the previous video we were discussing about this question. We have written the given data and we were talking about diametral clearance, that is d1 minus d2 minus d1 plus d2. It is given to us the difference between the wire diameters, that is d1 minus d2. It is given to us. So from this we have solved that d1 minus d2 is equal to 2d1, and from here we will put the value of d1, that is cd1, and d2, that is cd2, is equal to 2d1, and we have made the ratio of d1 by d2, that is c divided by c minus 2. We have put the value of c, and d1 by d2 comes out to be 1.5. So we have kept it as number 1. So we know that we have discussed the formula that w1 by w2 is equal to d1 square divided by d2 square. We just apply the formula, that is w1 by w2 is equal to d1 square over d2 square. So we have calculated d1 and divided by d2, that is 1.5. We put the value here and the answer is 2.25. So the ratio w1 and w2 is 2.25. But w1 plus w2, that is total load, we have given 5000. So from second and third, these two equations and two variables, we will solve the two equations to calculate w1 and w2. So W1 will be 3462 Newton and W2 will be 1538 Newton. Now we have to find main dimensions of both the springs. So in main dimensions, it means that the wire diameter and mean coil diameter, that is capital D and small d. So how we will calculate? So first of all we will calculate Wahl stress factor, that is K. Since both the springs has same spring index C, so K1 and K2 will be equal. So 4C minus 1 upon 4C minus 4 plus 0.615 upon C. So put the value of C and this is your Wahl factor. Apply the formula for shear stress, that is tau 1. Tau 1 is equal to K 8WC by pi d square. So we put the values of shear stress, Wahl factor, first load on the first spring, that is outer spring C, and we can easily calculate wire diameter of the outer spring, that is D1, and it is 8.83. We can change it to 10 by standardizing, and wire diameter is 10, and you can calculate mean coil diameter, that is CD1 is equal to 60 mm. Similarly, for inner spring, we can apply the same formula, tau 2. Shear stress 850 is equal to Wahl factor 8WC upon pi d square. So put the values and similarly you will calculate D2, and D2 is 5.88, or we can standardize it to 6. So we can also calculate mean coil diameter D2, that is CD2, and it comes out to be 36. Next thing we have to calculate is number of active coils in each spring, that is N1 and M2. N1 and N2. Whenever you have to find the number of coils, you apply the formula for deflection. So we know that axial deflection for the outer spring, that is 40. So axial deflection for the outer spring, that is, it is given to us, that is delta is equal to 40 here given to us. So we will apply the formula for deflection 8W c cube n by gd1. So just put the value of W1, C, G and D1 and you will get the answer of number of coils. So number of coils is 5.35, or we can say 6. So we will add 2 in the answer because we are assuming square and ground ends. So N1 dash will be 8 and the solid length comes out to be N1 dash into D1. So it will be 80. Similarly for second spring, we know that since the solid length of both the springs is equal, we can write N2 dash D2, that is solid length of the second spring, and solid length of the first spring, both are equal. So we'll put the value of N1 dash D1 and D2 and the answer of N2 will be obtained. So N2 will be 14 and we have to minus 2 from the 14, that is 12, These are active number of coils. Similarly, you have to find the free length. The free length, the formula is solid length plus deflection plus clearance. uh, Put the value of solid length given deflection and the clearance, you will easily calculate free length. And since the free length of both the spring is same, so we don't need to calculate twice. So remaining dimensions are like outer diameter of the outer spring. So d1 mean diameter plus wire diameter, this is the outer diameter. Inner diameter, mean diameter minus wire diameter, this is the inner diameter. So similarly for inner spring and inner diameter for the inner spring, these are the simple calculation work. This completes the numerical. Next is a theory topic, surge in a spring. So we can easily discuss it. When one end of the helical spring is resting on a rigid support and other end is loaded suddenly, then all the coils of the spring will not suddenly deflect equally because some time is required for the propagation of stress along the spring wire. What does it mean? See here, you can see from this diagram. That means if we apply load on the spring, sudden load, then the load in the spring will not compress the spring suddenly, but this deflection will propagate from this point to the bottom point gradually. Okay, so a little consideration will show that in the beginning the end coils of the spring in contact with the applied load takes up the whole of the deflection, and then it transmits a large part of its deflection to the adjacent coils. So in the coils of the spring, means if this is your spring, the deflection propagates from one coil to another coil. Means if the deflection start from here, it goes to the next coil, then next coil, then next coil. So if you apply the load from the top, the deflection of the spring will not happen suddenly, but it will travel from upper coil to the lower coils. After that, in this way, a wave of compression propagates through the coils to spotted end, from where it is reflected back to the deflected end. The wave of compression travels along the spring indefinitely. If the applied load is of fluctuating type, as in case of valve spring in internal combustion engine, and if the time interval between the load application is equal to the time required for the wave to travel from one end to the other end, then resonance will occur. So what does it mean? That if you are applying a fluctuating load, means you are applying a fluctuating load or shocking load as in case of valve springs, what will happen if the frequency of the applying load, that is if the frequency of the external load is equal to the natural frequency of the spring, that is the wave of propagation, the time for the propagation of wave will be equal to the time of the applying load, then the frequency of external load and the natural frequency of the spring will be equal, and in that case the resonance will happen. And when the resonance happens, your spring will vibrate violently, and due to these heavy vibrations your spring may fail. So this phenomena of resonance, where your spring starts to vibrate violently and can get damaged, this phenomena is called surge. So what will happen? In simple words, you can understand that if the frequency of external load applied on the spring becomes equal to the natural frequency of the spring, means the time required for the deflection to travel from the top to bottom. If these two things are equal, then the resonance will occur in the spring, and the result of resonance will be high amplitude and high deflection of the spring, and your spring will go through the phenomena called surge. So we will discuss this topic in upcoming video as well. Thank you guys.